Today I want to do a more freestyle session in which I want to explore using an LLM to do information extraction from a paper. So what that means is that I'm going to grab a PDF file and I'm going to bootstrap a Jupyter notebook using Llama 3 on the HPC, running on the HPC, and trying to get as much information out of it as possible. So this could be like a hybrid of RAG, but in information extraction. But the difference I could say that is that I am trying to elicit or change in real time what is the format. So I'll try to, like ask a question and get something that's machine readable. That means that that either could be JSON data structure or CSV or a Python pandas data frame, we'd say results out of a research paper. I have not done this before, so it'll be fun to see what happens. And if you have any questions, just interrupt me. We have an hour to try to make it happen. I'll start sharing my screen. So far, I have already on the HPC, I have an allocation on Ocelot, and I'm going to build upon Mithan's session from last week. I have Llama running here. So the way I'm setting up my environment is that I want to use the LLM on the HPC, but I want to run the rest of my code locally on my laptop. That way I can leverage, like having VS Code, but still I want to have a GPU to have a quick turnaround time, or maybe if you say don't have a GPU, you don't have a gaming machine or a MacBook Pro with the Apple Silicon chips, this is going to be really useful and it's going to be faster than whatever you may have on your laptop, unless it's like a 490. So the way to pipe this into your own computer such that you can use it seamlessly is using SSH. I just want to point out that if you go to the HPC documentation, there are instructions on how to SSH directly to the node that you already have. So you could just go and search VPN or VPN, connecting to the HPC VPN. And doing that, like if you have already, hold on, this is not the one I want to. Yep. If you've already connected to the campus through the VPN, you can use Cisco AnyConnect. So the only difference is that you'll need to change the host to vpn.hpc.arizona.edu, but you'll use your NetID with your own password. If you have the dual two-factor authentication, you'll get the notification. Once you have that, then you can connect through SSH. I'm going to show you in a bit what does that mean. I, ahead of time, created the allocation on the HPC using Open on Demand. So we've seen this before. You request a Jupyter notebook on one of the clusters and specify that you want the GPU. That's critical because we want to run Llama on the GPU. And once you have that, you can open shell here. I already have Llama installed following Mithun's and Rap's instructions from last time around. So it's here. So next key piece of information that you need to pay attention is here to this I16N7. That is the actual blade server that is running the job that we allocated for. What we want to do is that we want to SSH into it and do port forwarding. So that means that, say we start, this is a command prompt. If you have Linux or Mac, this will work out of the way, out of the box. If you have Windows, you can use WSL. we could have another session to explore that as well, but this is adjacent to the goal of today's session. So I'll just blast through it, and if you have questions, just stop me and we'll chat about it. So you need to SSH, specify your username at the actual identity of the server blade dot the name of the cluster. So here's ocelot.hpc.arizona.edu. But
Enrique, are you doing this from the Bastion host or is it your local laptop?
It is on my local laptop because I connected to the VPN.
Okay, cool.
So if you're not on the HPC's VPN, this won't work. But if you are, it'll work. So something else important is that we need to pull down Llama's TCP port. I don't remember what was it. I think it's here. It's 11434. So 11434 dot localhost 11434. For now, you can just trust me that this will work. I hope not to let you down. And we're in, so you see that we are here. What I'm going to do is that I'm going to open another tab, and I'm going to call Llama list to see what do I have installed. This is just for testing. So I want to see, say, please tell me the Constitution of the USA. And let's see, what do we have here? Yes, we have an API call. So here we're getting it. It is fast enough so you know that it's running on the HPC or on the GPU. And then just gonna say bye. So what just happened is that we have the Llama server running on the HPC, and the Llama client is running on my laptop, and they're connected through the VPN. And we can minimize that now. And I'm going to move to VS Code and start creating a Jupyter notebook. So what we're going to do is that first we need to install the dependencies. So I'm going to make use of LangChain. Install let you LangChain core, LangChain Llama, I think it is. Let's see if this works. Okay, so then from LangChain Llama port chat Llama, then we're going to do create an LLM instance called chat Llama model. So we had Llama 8V. I think this works. Invoke. Hello, who are you? We're going to print this. No, just like that. Okay. We are in officially. So we are connected to the LLM. Now let's get to the actual application. So what I want to do is that I want to take this PDF and then I want to ask it questions. So let's assume that I want to know which are the different type of layers and what are the parameters in it. So we have all this bunch of numerical informations or definitions of the architecture. And say that I'm lazy or that I'm in a rush and I don't have time to read all completely, but I already sort of know my way through it. So I can fetch, I can use information extraction for this. There are also some tables if we scroll down, like this table too. I'll try to get this table as a pandas data frame. I don't know if I'll succeed, but I'll die on the line. So the first thing that we need to do is that we need to read that PDF as text. So for that, recently a colleague of ours on DSI pointed us to Duckling, which is a really cool Python library to process PDFs. It actually works pretty well. So we're going to install it, and then we're going to process that PDF, and we're going to get the plain text out of it on a clean format. So you just need to Google GitHub Duckling, and you'll see by the icon that this is what we're looking for. And the way to use it is just straightforward, follow the installation instructions, and there's some examples here. We'll just copy them and add them to our notebook. So here, pip install I do. While it finishes installing, let's copy this, paste it here. But as source, we're going to just say bird.pdf. Now let's wait for it.
Enrique, on the original SSH, when you were connecting, did you
Yes.
say that the command for that is different in Windows?
No, it is the same command, but the way to get the shell is different depending on whether you're on Windows or you're on a Unix-like machine.
Oh, okay.
So Mac is Unix under the hood, so it'll work. When you're using Windows, you can install with the Linux subsystem for Windows, and you get a bash prompt. Bash is the name of the shell.
Okay.
And you can pretty much do whatever you could do using, say, Ubuntu or any other Linux distro.
Thanks.
But once you're into the shell, the command is the same. Okay, so it seems like we already have Duckling here. So now what we're going to do is that we are going to load the document converter, specify the path to the PDF, and parse it and export it as Markdown. So
I have a general question, Enrique. How is the thing that you're doing right now different than a retrieval augmented generation? Is there an advantage or a disadvantage?
it is, so a retrieval augmented generation, it's similar to this, but right now what we're doing is that we're just fetching the contents directly into memory. In RAG, what you have is a vector database that contains a large collection of documents. So this paper could be one of those. But you could have, user manuals, you could have literary work or whatever, and then you retrieve a subset of those using a query. then you get that, and then you do the step that we're doing here. So in a sense, this is kind of like half RAG, because we are not going through the retrieval phase. Instead, we are just concerning ourselves into how to use the LLM to get the bits and pieces of information that we already know are contained in that document.
Nice. So this is a quick and dirty way of, if I'm given like a 27-page research paper, this is a quick and easy way of quick and dirty way of asking it questions.
Yeah, more or less. So 27 pages is a little bit long, but say the latest models like Llama 3.1 support 128,000 input tokens, and that's like ridiculously long. So you actually, we were testing today, passing the complete Harry Potter Volume 1 book to Llama, and it worked. So, but that's like a whole other beast by itself, because even if it works, the self-attention mechanism on the LLMs is quadratic in complexity. So it'll work, but it'll take hours to finish. In this case, like, this is a single paper, I think it's like 8 pages, so that should be okay. So what is going on right now is that Duckling is a package that leverages multiple AI existing models and components, like the table former, which is a specific transformer to read tables. It has an OCR model, and then it puts together all those things and consolidates the output into a single format. So now I think it's finished. Let's see if we have contents here. Okay, so looks like we do have it, but let's see. Let's see if we can show it nicely. There we go. So let me split this. Let's just follow through. We have the title, we have the list of authors, the abstract. So introduction, background, model architecture. So one thing to have in mind is that presumably Duckling also fetches the images, but having being able to do it successfully, it crashes anytime I request, like, say that I want to pass this image that I have on the right through a vision LLM. I cannot do it because I'm probably doing something wrong. About the math symbols, it does get them, but it is not very good yet at rendering LaTeX out of those. But it doesn't really matter. So what I want to get to is here to the tables. So it is actually quite good at getting tables. Here, regularization. I wonder if this is table 2. Yes, this is table 2. Let's see if later on we can get this to be a pandas data frame using the LLM. Results with this table as well. And then at the end, we got the references. You can see how it even puts together a table with the papers that are being cited along the article. Okay, so far so good. These are the appendices. They're just images, so they won't show here. So we have Markdown. All this is in a variable called Markdown. Let's see if we can design a prompt template that will allow us to reuse this using LangChain as well. Prompts, port, chat, on template. Template equals so when you're using an LLM, you have this notion of a conversation. So conversation is going to be asking back and forth things between the LLM and yourself as the user. And the way that you define whose turn is it at any given time is by giving an identifier. So when we are using LangChain, we're going to use human and AI messages. To specify who's who. Usually it's like the first round is the human, which is us, and then there's always going to be a response for each human message. So I say something, then the LLM says something else. Then I say something after the LLM replied to me, and the LLM will reply. And the reason for this is that you want to have this incremental notion of a conversation being developed. And anytime that you get to ask something, the LLM is going to look at the whole history of that conversation. So you're establishing context each time that you send a message to the LLM, and you don't have to repeat yourself. So with that said, we need a way or a data structure to manage that. Usually all the libraries such as LangChain, Llama Index, or Llama have their own classes to define the templates that do this. Or even if you interface directly with OpenAI's client library, they'll use this. So what we want to do is to create a pipeline in which we pass the template, and then we call the LLM, and then invoke we're going to with something. So we're going to call this message. Then we're going to add here a placeholder. Sorry, this should be message. So let's see, what do we get? Okay. Let's say that I say hola, which is Spanish for hello. I expected to reply on Spanish, like hello, how are you? Okay. So this is not really that interesting, but the interesting here is that there's a third type of message that we're going to call system. A system message is a way to configure the LLM to behave with certain behavior, pardon my redundancy. So here we're going to tell it you are information extraction AI system. You will look at the following paper, research paper, and ask questions. Sorry, answer the questions of the user. Then So I'm going to close this for now. And is this large enough to be read? Okay, I hope so. So you are here in the paper, and we're going to add triple backticks paper. Yeah. So this strip. So you can see the pattern here, like we have placeholder variables, and then we can add more fields, such as example paper. And as you remember, we have the contents of the paper here in the markdown variable. So now let's say ask, what is the title of this paper? Let's see what do we get. Let's see, what is this? Okay. So from template. So now I'm just troubleshooting. We're gonna pass this. So whenever I got it incorrectly, I got to the documentation. Let's see if we can find one quickly here. Oh, I see. This needs to be. There we go. So the problem was that we need to define a list with the different messages. So the first one is the system one, the second one is whatever we want to do. And I was missing in Python, like, you know, you have the square brackets that indicate that this is a list or an array. I was missing that. So with that out of the way, let's see. I apologize, but you didn't provide any paper or text. Really? Sure. Okay, what is markdown here? So let's have a new cell. So what happens if I say, so this, but instead of the whole pipeline, I'm just referring to the template. So yes, we get that. Hmm. Let me go here to see if something is truncated. It doesn't look like so. Okay, so let's try something different. Question, then paper.
Also, are you passing the variables correctly? You're creating an object for template and you're calling chain.invoke. Shouldn't it be? All right. Yeah.
Yes.
Never mind. Okay.
Yeah, I tested that here, and here's the content of the paper. So I'm wondering if there's any truncation going on. So sometimes you need to do a little bit of prompt engineering.
Is there a default token limit?
There should be at least 8,000 tokens. Let's try summarize. Give me a summary. Okay. So let's do pprint. Okay, this paper appears to be a collection of references and figures related to attention mechanisms in neural networks. Figure 3 shows. Okay, so this seems to be a legit summary. Now let me define function. Call structure. That's going to take contents and command. And what it's going to do is to execute this. We're going to replace this by command, and this by content. So I'm just trying to save myself some lines of code every time I want to test something different. Then let's try extractor markdown, and then So I just want to display it better. Okay. So this seems to be a the list of references. So let's try to iterate here. But instead of returning something, let's print it directly. And this will be the foundation, and we have 20 minutes to try to fetch whatever else we want to do. And let's see if this was split through right. No, this is incorrect. So, okay. The first thing that I could try is that I want to get rid of the first couple lines. So this is the provider attribution. We just pass in the subsection that could be relevant. So let's try this. Markdown.split. Let's see the new variable. So here I got rid of the first line, the one that's red on the right. And I'm going to use this contents. And ask it, tell me the name of the title. Let's see. Okay. Okay, so this is partially right. I mean, we got the title, and say that we want the extractor contents. Tell me the list of authors. Okay, this is still referring to the references. So what we can do is to help it out, giving it an example. So the authors are usually spelled out at the beginning of the article, and they contain full name, affiliate, and email address. Let's see if this helps. It is stubborn.
What would happen if you just asked it to list the authors of this paper or wording like that?
Yes, that's a good idea. Okay, not there. So something else that we can try is that we can select just the beginning of the paper by choosing the first 1,000 characters. There we go. So, I mean, I could, if I was reviewing this, I would tell you like you're cheating because you're constraining the input just to have whatever you need. But in reality, when you have a long document, it's really easy to trick the LLM, and we see that we were requesting something that looked and got something back that looked similar. So we got a list of references, and those references have names in it. And usually that is at the end. And sometimes there have been some papers that mention that the LLMs tend to pay attention mostly to stuff at the endpoints of the document. So that might be one reason for that. And you could just basically do some pre-processing step in which you just split by section and then ask the questions point-wise to the relevant section. So for now, let's just continue with this example of the authors with this constrained setting. Let's see if we can increase that context window a little bit more to remove that noise from the tail. And now that we got this, I want to get it in a structure format. So this is a string. So if we print this, we'll get that enumeration of authors. But I actually want a Python function with it. So you can just to do that. Let me make this nicer by splitting it. Python list. So we actually have the names here. But we want to get rid of this prefix and suffix. Don't. So you need to emphasize that. Don't elaborate. Just output the data structure. Let's see if this helps. Okay, got it. So far so good. If we were to eval this, we can we actually get this. This is a Python. So we actually get that list in machine reading code, machine readable code. But we can go further, right? So we could use another element from LangChain. So we can use the LangChain output parsers, import JSON output parser, and we can add it here to the pipeline. So it's going to take the output of the message. So let's just comment this out and try running this again. JSON data structure. And let's see if we actually get it as a Python. In this case, it's going to be a Python dictionary because this is a JSON data structure. Hold on. So let's do return response. So a way that we can help out is by adding an example. For example, is going to be author. Name. Affiliation. Oh, there needs to be a comma here. Let's see if this helps. Nice. Okay, so we got it, right? So we got an author here. Well, not exactly, but like we can specify it a little bit better. It gave us a authors. So we go here. Okay, now we got it. So Lilon Jones, is he mentioned here? Yes, so we have Vaswani, Shazir, Armor, Jacob, Lilon, Aiden, and Lucas. Oh yes, and we have Ilya. So with this one example, so as you can see, it takes a few iterations. You need to reduce the noise. You need to elaborate the prompt correctly, and then you need to provide examples of the data structure that you need. So let's see if we can do something to get the table, the results table. So for that, I'm going to do a new pipeline. So chain to is the temp. So we're going to define a new template. No, template. Do we? No, let's just use extractor. It's in Markdown. Generate a CSV file with the contents of which table do we want. Let's find the table tree. So I don't know what's gonna happen. Let's just test it. So we have 7 minutes to make this work. Again, it's going to the references. So let's see if we can do. I'm gonna create a new cell down here, markdown, and see what happens if I do the minus 300. I want to just remove the references. We still get the references. Okay, 5,000. Scrollable. We get to background. So let's see if we do the 10,000 character. We're almost there. Yes, so it's right here, right? So let's just okay. Let's get rid of let's get rid of this JSON parser right now and see what's the actual text that we get. Okay, so it certainly looks like something. However, I'm not sure. So it's giving us table 4, right? We can work with this. Let's see if there's a pandas data frame as output parser. So let's try this here. Let's just add it. And just run the same thing. We don't want to use content here. So let's install pandas. Data equals this. Okay, and that data looks like what? From pandas work data frame. Yes equals data talent. No. Data frame. How does this look? Well, some another hurdle is that it's giving us a different result each time, which breaks the formatting. But that is something that can be fixed by setting the temperature to 0. Let's see. Cursor training. Yeah, but okay, so we are at time. So unfortunately, I have to stop. But I think that we were able to get pretty far. The takeaway is that it is possible to extract information using LLMs. However, it's not an exact science, especially if you're using an out-of-the-box LLM that's not fine-tuned specifically for this. So what you need to do is that depending on what's the input source that you have, you need to fine-tune a prompt or prompt engineer message that works for the LM. So you're targeting a specific LM such that you get the actual format that you want. Sometimes you will get the data, but there's going to be fluff around it, like here is what you were asking for. I hope that you liked it. You want to get rid of that by prompting the LM to be succinct and do not add stuff. Eventually, you can make this work. We use the LLM running on the HPC, and we use the Jupyter notebook, and we're able to get a good quality of text output from a PDF. So I hope that this was useful. And yes, I'm interested in making this a more approachable task by researching methods to do information extraction over this type of documents. Great. So thank you, Jonathan. Yeah.
Thank you.
Okay, thank you, Jake. So if you don't have any more questions, then we can stop here and we'll see you next week.
Yeah.